All right, in this video, I want to go over the top 5 literal equations that you need to know. Because we all know, in reality, your teacher only goes through a couple examples in class, but then there's always something that's a little bit different that shows up on your homework, that shows up on the quizzes and the tests. So I'm hoping these 5 videos are going to give you enough variety that you're going to have some confidence to be able to solve literal equations on your own. Okay, so the first example is going to be a linear equation. Now, this is probably one of the more classic types of literal equations that you're going to see, as well as do for the rest of your time in mathematics. So what we have here is a linear equation that is in standard form. And what we're doing is we're solving for y, which is going to put it into our slope-intercept form. So what I always like to do when I'm solving for y, I want to make sure that I isolate, or I get that y by itself. So I'm going to put a box in there, and that's a way for me just to kind of understand what exactly is happening to my y. You can see that it's being multiplied by a 4, actually a -4, and this is a positive 3x, so we're actually adding a 3x to it. Now, sometimes students will get confused when it's written like this, so I always tell them we can always rewrite it like this, y plus a 3x equals 8. Now, it might be a little bit easier or obvious to see, oh yeah, I'm multiplying by a -4 and I'm adding to a 3x. Now, all we simply need to do is apply our inverse operations. We always want to undo addition and subtraction first, so I'll subtract a 3x on both sides. And typically when we're subtracting a 3x from the 8, we always want to go ahead and write that in front. And then we see that we have -4 times y, so we want to undo multiplication by dividing a -4 on both sides. Now, just make sure, since these two terms up here are separated by addition, you divide this -4 into both of those terms. Negative divided by negative is now going to be a positive, and 8 divided by -4 is going to be a -2. Okay, so the next one is going to be a formula. Now, we do this actually quite a bit in geometry class, and there's a lot of formulas that have multiple different variables. But what's also important about this one is going to be actually the factoring out, or the combining of your terms. Now, in this case, what we're actually going to be looking for is solving for our L. So you can see here, we actually have 2 L's. And so part of the formula, a lot of times you'll have, sometimes multiple variables. But in this case, what I want to be able to do is I want to be able to get these L's kind of next to each other. And ideally, if we can combine them, that'd be great. Because when we're trying to isolate a variable, we can only have one variable equal, right? We have to have y equals, or in this case, L equals. So let's go and rearrange these so my L's are right next to each other. Okay. So the L's are right next to each other, right? The two terms. Unfortunately, though, this has a W, this has an H, so I cannot combine them. So what can we do? How can we still isolate this so we can get one L? Well, if we cannot combine them, we do recognize that they both share an L. So what we can do is factor out that L. Remember, the process of factoring is rewriting an expression, in this case, these two expressions, as a product. So what I can do is if I factor out or divide out this L, what I'm going to be left with is a 2W plus a 2H. Now again, you can always go ahead and check your work here, because if I take this L and I multiply by 2W, I have a 2WL, right? If I take this L and multiply by 2H, I'm still going to have a 2LH. Again, order doesn't matter. 3 times 4 is the same as 4 times 3. But now, ladies and gentlemen, I have one L. So it's just like over here. I have L being multiplied by this expression, and it's being added by a 2WH. So again, applying your inverse operations, I'm going to subtract 2WH on both sides. And now, to undo multiplication, all I'm simply going to do is divide by 2W plus 2H. Now, I didn't like having the L on the right-hand side, so I went ahead and just went and flipped everything. But you can see here now, by applying these inverse operations, I now have the expression where my L is going to be isolated. All right, now on to number 3, all the variables. All right, so here again, we have another formula in this case, but really the important thing that I want to look at is a lot of times students really get confused with solving literal equations when there's no numbers at all. And again, the process is going to be exactly the same, but just adding a couple like 2's and 3's make usually the process really easier. So that's why I wanted to start with those first 2 examples. But in this case, again, we just need to understand what it is we're trying to solve for. We're trying to solve for this G. So we need to understand what are the operations that are being applied. Now, in this example, you can see I'm being multiplied by an m with a subscript 1 and an m with a subscript 2, as well as being divided by a d squared. Now, we can go ahead and apply each operation individually, or we could actually apply them all at one time. I think the main important thing that I want to do first, though, if I was going to at least apply one operation and then I'll combine two other ones. I don't like having a d squared in the denominator. So the first thing that I would do on this problem is I get the d squared off the denominator. To do that, I'm simply going to multiply a d squared on both sides. And you can see when multiplying here that d squared is in the numerator, so anything in the same in the numerator, denominator is simply going to divide out. And then we have a d squared times f over here. Now in this example, you have g times m1 times m2, right? So I could divide them individually, or I could also say, well, why don't we just group those two together and just do them at the exact same time? Since they're both being multiplied by g, we can also just divide them at the same time as well. And there you go, ladies and gentlemen. We have now went ahead and solved for g. All right, now here's another example where we're going to have two variables. So it's going to involve the factoring out like I previously did. And then again, this example has not only a variable in the denominator like we did over here, or sorry, no, we didn't actually do one with the denominator here. So here we actually have a variable in the numerator, which I called up just to make things simple, as well as in the denominator. So what are we going to do on a problem like this? Well, again, just like we kind of did over here, when I have something in that denominator, to get rid of it, I'm going to multiply that on both sides. So if I have ab in the denominator over here, what I'm simply, first step I'm going to do is get that variable, right, off the denominator. So I'm going to multiply by an ab on both sides. Okay, so now I got the variable off the denominator. That's good. But I still need to solve for a. And unfortunately, I still have two a's. And if you see, I got to get the a's over to the same side, right? If I'm going to combine them or if I'm going to factor them out, they at least got to be over to the same side. So let's subtract the a over. Okay, now again, I want to subtract these, but I can't use the combined like terms anymore because this has a bx and this does not. So what I need to do, again, is go back to my factoring. I can factor out this common term of a from both these expressions, and that's going to leave me with a bx minus 1. Again, always go back and check your work. A times bx is a bx. A times negative 1 is going to be a negative a. Now, ladies and gentlemen, you can see that my variable has, I only have one of those variables, and it's being multiplied by the expression bx minus 1. To go ahead and solve, I just need to divide by bx minus 1 on both sides. All right, so there we go in for solve for a, and now we're into our last one. All right, now again, we have another formula, but again, really the formula, and we have one, almost all variables, we have the 1/2. But in this case, what we have is actually something that's inside of parentheses. So we need to understand, well, why do we have parentheses, and how can we get rid of the parentheses? So we need to go ahead and solve for b1 in this case. And there's a couple ways we could actually go about this. You see b1, yes, it's being added by a b2, but I can't undo that operation until I get rid of the operations that are outside of the parentheses. So I could get rid of them by actually using the inverse operations, right? Technically inside this parentheses, I'm multiplying by an h and I'm multiplying by 1/2. So I could just undo those by dividing by an h and dividing by 1/2. You could also get rid of the parentheses by actually applying the operation. If you just multiply everything times 1/2, and multiply everything by h. I don't know why, I just kind of feel like actually applying the operation might just be a little bit easier for me to be able to work through this problem. Okay, so what I did is I just applied multiplication here. And again, we're just trying to solve for the b1. And so now I see that, well, my b1 is being added by this expression. So let's go ahead and get rid of that. And I think definitely it would have been easier just to undo the operation first and then subtract the b2. But either way, we'll kind of get through it. Now, let's go ahead and to get rid of multiplying by h, I can divide by ah. And then to undo dividing by or multiplying by 1/2, I could divide by 1/2, which is the same thing as actually multiplying by 2. So now, if I multiplied by 2 in this case, you can see the 1/2 times 2 is going to go to 1. The h's are going to divide out, and I'm going to left with b1 is equal to a 2a minus 1/2 b2h, and that's divided by an h. So let's see, actually those are going to divide out. That is going to go to 1, so b1 is equal to, let's see, that would be a 2a minus a b subscript 2. Which, again, let's just go ahead and do this real quickly. If I had this, a equals, if I multiplied by 2 and then divided by h, oh yeah, I gotta have this divided by h. The h divides into both of those terms, right? There you go. And divide those by h, and then yeah, minus a b2. it would be much easier actually to apply those inverse operations. I don't know what I was thinking, but either way, hopefully you guys have taken back some of these ideas for solving your literal equations, and it's going to help you on your next test.